So let's go back to our CloudFormation. Open that up. Actually, before we do that, let's add our new stack that we've got. So we've got our parameters in there, we have our log group, we've got our Lambda security group, we have our execution role, our IAM role for Lambda, and we have the Lambda definition itself. So creating initial workload, CloudFormation template to deploy Lambda. Cool. Alrighty. So now we're going to deploy our load balancer and we'll get Lambda in a target group for that. So there's a few resources we're going to need. So let's flesh that out a little bit. So we're going to have the Lambda target group. It's obviously something, whoops. Get there eventually. It's something that we're going to need. We're then also, obviously we want our load balancer. And we're going to need load balancer listener, because we need to tell the load balancer what it's there to do. And we're going to need, the load balancer itself is going to need a security group. So let's start with these 4 resources to deploy. We need to make sure we align everything appropriately as well, otherwise CloudFormation won't be too happy. So the target group, let's get that one in there. So the type for that is going to be an AWS EC2, no, let's go back, Elastic, load, balancing. Now this is a V2 resource, we're not using the legacy ELB stuff. Target group, so we want our load balancer target group. We're going to give it some properties, like we've done with all our resources. So its name, we will give this, substitute in some variables. It can be our repository name. For the Lambda. So the reason that we're going to have dash Lambda is because we're obviously going to deploy our ECS target group in future. So this will just differentiate between the two. Target type for this group is obviously going to be Lambda, lowercase lambda. And we need to give it the targets that we're going to hit. So that's a list with an ID. And we need the Lambda ARN. So in this case, we'll do get matter double T Lambda ARN. So Lambda being our resource here. Yes. Okay, so that should be fine. Well, security group's quite simple. Let's pop that one in there now. In fact, we can probably even copy what we've got up here for our Lambda security group. So if we bring that down, we've got our EC2 security group. This one is for our load balancer. Okay, and that's going to our same VPC. Cool. So now the load balancer itself, let's typing this out again. Let's just copy that. Elastic load balancing v2. Load balancer. It's got some properties. So obviously we need to name our load balancer. Oops, and we want to make that another ref. Our load balancer, let's just give it the same. It can borrow the repository name for now. We can come back and refactor that into something more useful at a later date. The subnets that the load balancer is going to live in. So we have been using the default VPC in this account. So the default subnets that are there are the same. They are public. So it's perfectly fine for our load balancer to go in there. Our Lambda's in there as well. If it needs internet access, it can go out the same gateway. Okay, so now we want to ref. This will be our subnet IDs parameter up here. Subnet IDs, yep. Okay, and we need to give it our security group, which we've just created above. So that's another ref, and it'll be load balancing security group. So that's that one. Actually, according to documentation, security groups is a list. So let's make sure we get that right, because that's just going to cause us another problem. All right, scheme for the load balancer. So is it an internal facing? Is it internet facing? In our case, internet facing is what we're after. So we'll configure that. Type of load balancer that we want to deploy. We'll have an application. And we can configure any number. So you can support any number of different attributes that have been documented by Amazon. In this case, I only really want to include the idle timeout. We'll just default everything to 60 seconds. That way we can decide at a later date if we need to reduce that or potentially increase that. In this case, everything's very quick, so we'd be more likely to reduce it if we needed to. But 60 seconds is a reasonable default. You could probably get away with just leaving this one absent, as that should be the default behavior anyway. So idle timeout and timeout seconds is what we're going to define. So we'll add that in, timeout seconds, and the value for that is going to be 60. Cool, so that's our load balancer. Now our load balancer is going to need a listener. Without a listener, we're not exactly going to do a lot, so we'll need to be able to define where we're getting our traffic from. So the type is going to be another one of these elastic load balancing v2. In this case, it's a listener. Properties, load balancer ARN. So we're going to reference our load balancer resource above, and we will listen. We're not using HTTPS at the moment, so this will just be port 80. It'll be plain text, and we'll define that by setting the protocol to HTTP. Cool. Protocol. Spell it correctly. Oops. Okay, so that's our listener, which is hooking up to our load balancer. Okay, so let's add a rule to the listener. So you can add as many rules as we need to, so we'll just define a single rule at this time. So elastic load balancing v2 listener rule. Okay, so actions. We're going going to forward our requests. Where are we going to forward them to? So our target group, ARN, is where we're going to send them. So send it to the Lambda target group. Listener ARN. And that's going to be a load balancer listener here. So that's what we're going to apply this forward action to. So we're going to forward everything to the Lambda target group from that listener. We should probably define a priority for it as well. So this just allows us to set that ordering of our listener rules. Okay, so we've got a load balancer and a listener. We have the ability to forward requests to our target group, and we have a security group for the load balancer itself. Now, the security group doesn't have any rules in it, so given that we want to allow internet access, let's go ahead and do that. So we'll define an inbound rule, which is an AWS. Now we're back to EC2. EC2 security group ingress. It's an ingress rule. Okay, so the IP protocol that we're working with is TCP from port 80 to port 80. We only want to expose the one port. We'll give it a CIDR range. So in this case, we're just allowing any traffic to come in. So we'll just do 0.0.0.0/0. So that is the internet. And we need to assign it to a group. So let's go and grab, what do we want to get? We want to get our group ID from the load balancer. So we can probably use another get atta or get attribute. We're going to get that from our load balancer security group dot group ID. Okay, so that should apply our rule. Port 80 from the internet is allowed to hit our load balancer. Okay, and we've got our target group. All right, something that we haven't done is actually allow the load balancer itself to trigger Lambda. So we need to add a permission for that. So let's go ahead and do that. So I'll call it ALB permission for our load balancer. So that's an AWS Lambda permission. It's got properties, as does everything. So the function name, another get atta for our Lambda ARN, and it's the B, Lambda ARN. Action, now we need to invoke the function, so the action will be Lambda invoke function, if I can type properly. Lambda invoke function, we need to define our principal. who is invoking this function. In this case, it's the Elastic Load Balancing service. So Elastic Load Balancing, Amazon AWS.com. Cool. A couple more things, source ARN and source account. So let's source account, which is, we can just reference our handy little helper variable, AWS account ID. That's going to be super useful. Source ARN, and this is going to be our target group. Now there can be some challenges with causing circular dependencies here. So I wonder if we can grab the target group. So the challenge we get here, because we're needing to deploy Lambda, we need to deploy a Lambda that needs to be a member of a target group. But the problem that we will face is that we can't bind Lambda to that target group without the permission. So we almost end up with a race condition here. So we need to work around that by decoupling it a bit. So we're referencing the Lambda. So the Lambda needs to be generated so we can get the ARN. So if we construct the ARN for the target group, we'll decouple ourselves from that, and it should allow this permission to be deployed irrespective of which one came first. So we can create a ARN string for that. So let's do that. AWS Elastic Load Balancing. Yes, I spelled that correct. Yep, is the service. We can borrow our helper things again to get our AWS region, which is there, for our account. So making sure that it's our resource, AWS account ID, and then we're going to specify our target group that we've got here. So we're going to borrow this name. So before we paste that in though, we need to tell Amazon this ARN is a target group, all lowercase in this case, slash, and then our repository name Lambda. And in case we've got, in this case we get a auto-generated string, so let's just map that to everything. Okay, so if we've done this correctly, we've constructed the ARN for our account in this region for a target group. Target group, yep, spelled right, slash, and then it's going to be the name of our target group, matching anything else on the end. Okay, so that should work. But now that we've gone and created that, we don't get the nice lookup of dependencies. We don't get a dependency graph like what we would normally get with these resources. So the way we can fix that, we need the target group, because target group is referring to, okay, so this needs to be deployed before our target group. So we've decoupled it by giving it the string ARN to the target group. So in here, we can put it depends on ALB permission, and then that's going to help keep things deploying in the right order. So the target group for Lambda will wait until this resource has been deployed before it then tries to create itself, adding the Lambda, which it now has permission to execute. Hopefully that makes sense. We'll certainly see when I go to deploy it whether that causes any errors or I've correctly got that working. Otherwise, what happens is we just end up with kind of a circular dependency, things referring to each other, and there's no clear way of what goes first. You don't really have a clear order of precedence. So that's what we're trying to address there. Okay, so yeah, there's our permission. We have our Lambda target group, security group for our load balancer, which allows the internet in. We've got the load balancer, which has its security group, it's internet facing. We're allowing port 80 through, that's our listener. And we've got our first rule that forwards to Lambda. So we're currently just forwarding everything. So if we think about that for a minute, our Lambda is returning static artifacts. So we're really only getting stuff. So there's we can actually make this a bit better. So let's put a condition in here. And this condition, we can actually specify a field. This is going to be HTTP request method. And then HTTP request method config. And the values that we will accept on this forward are, let's do get or head, given that head's effectively a read as well. We're not properly supporting head at the moment in our Lambda, but it seems reasonable that we may wish to do that in the future. So this condition will only allow forwarding to Lambda if the request is a get or a head. So we don't want anything else. So at the minute, it's a bit of a black hole. So we can address that. So up here with our Lambda, we've actually got a default action we can provide. So it doesn't have to be another rule. So this will just be for anything that falls through our rule list. So let's go and do that. We'll use our default actions. It's a list of actions. So in this case, it's just going to be a fixed response. So we're using this to pretty much just tell every other request that comes through for something that's not a get request or a head request that we don't support that. So we do that with a fixed response config. Need to ensure I capitalize the R. Okay, so fixed response configs. We need to give it a HTTP status code, the message we want to return, content type. So let's just keep this simple. HTTP status code for method not allowed. So for anybody who's not familiar with those HTTP methods, we can look them up. Let's Google that. HTTP methods. So get, head, post, put. There's a whole bunch of different things, and what we want are the response codes for these. So let's. This is the way we expect the load balancer to respond to a request. So this will be a for something because it's a client request. The client is requesting it. It's not the server failing, which would be a 500. So if we come down to 400, so unauthorized, we're not authorizing anyone. So it's not an access related thing. It's not that it doesn't exist, which is 404. Here we go. Method not allowed. Request is unknown by the server. Sorry, known by the server, but not supported by the target resource. Yeah, that sounds pretty reasonable. So we'll do that. Not acceptable. Response is sent to the web server after performing something else. Yeah, so we're not doing that. So 405, that seems like what we want. So let's go with that. 405, and we need to give a message back to the user. So message body is what we're going to inject, and we'll just keep it super simple. We'll just put some plain text in. So method not allowed is what the 405 response code actually is. So we'll just pop that in there. And we need to specify the content type. So the content type of this is just plain text. So text plain is the correct syntax for that. Cool. All right, so we have a default action on our listener, which is going to send a fixed response of method not allowed if it doesn't meet any of the rules that we define. So we've just defined get and head. We don't accept post or delete or any of the other ones. So that should service us quite well. Rightio, load balancer. I think we're about ready to give this a shot. Anything else? So we've got our dependencies. Fingers crossed this works. We may need to do some triaging here. And yep, looks as good as I think it's going to get at the moment. So back to our make file. Let's do a validate and just double check that it's still happy, which it is. And now we'll deploy our workload. So this is going to go and give us another update to our stack. And if we've done everything correctly, we should now end up with our load balancer resource with the correct permissions to update, or sorry, forward requests to our Lambda. No, we've managed to break it again by the looks of this, which is unfortunate. Okay, so what have we done? Okay, so the listener rule isn't valid. Doesn't like the condition. Condition. Okay, let's have a look at that. So here's our load balancer rule. Okay, so this is a list, so the key is probably conditions, not condition. Now this stack has rolled back, I believe. Yep, and it's rollback complete, so we should be able to deploy this again. Let's give it a go. And I might just speed this one up in post-production just to make it a little bit easier for everybody else. A little bit more space there for visibility. Create failed on the permission. Okay, so we not got this right. Principal. Okay, it's probably that we are supposed to have principals. No, principal. Or have I spelt it wrong? What have I done? I've spelt it wrong, I think is what I've done. Okay, we can fix that. Where's our spelling mistake? Principal. That'll fix our permission issue. Let's have a quick look at what else have we got here. Is there anything else that stands out? It's incorrect. That looks okay. Spacing and tabs look okay. Face here, that looks alright. Well, that doesn't look right. Okay, there we go. Fixed up the spacing. Alright, let's run that again. Okay, so the update to Lambda worked. What failed? Load balancer security group. Failed to update Lambda. Oh no, the Lambda update didn't work. Why did that fail? That failed because... valid source image. Okay, so the source image doesn't exist in our repository. Go in here, you can see that. Okay, so what's happened is we've made some git commit changes, and if you remember from the first video, the make file uses our current commit SHA to create the artifact version, so the short one. So all we need to do to address that one is build the latest. So we'll quickly do that. We should see that this is able to actually push up quite quickly because the layers all exist. Excellent. All right, so that's done. And if we go and run our deploy once more, fingers crossed this time we'll have a success. Jump back over to CloudFormation. Let's wait for the stack change set to be completed. All right, here we go again. So sometimes this is a bit of trial and error, quite often a bit of human error, as we've seen with what I've been doing. But at the end of the day, once we've got our infrastructure as code all configured and set up, everything's there to be used as needed, and it's easily reproduced, which is fantastic. It's the value you get out of defining your infrastructure as code. If you get too involved in ClickOps and manually create your resources, especially if you start cleaning things up, things get missed. You get too many changes made by individuals who possibly don't have the right context. They might type something wrong, and you just end up having a lot more trouble with it. So always good to use infrastructure as code. Jump to resources, so we've got a few more resources in here. Our load balancer has been deployed now, excellent. Security groups are there, target group. So we must be just about complete. Looks like our permissions are successful this time. Okay, target group. What are we waiting on? Lambda updates complete. Complete. Load balancer security group. Is it the load balancer itself? Is yet to be complete. Okay, so it was defined, but it's still provisioning. And that was our previous run. Okay. So we'll give this just a little bit longer. Oh, here we go. Okay, so our load balance is now complete. And we're just configuring our listener. There we go. Everything's green. Fantastic. That's what we want to see. So we'll come back over here so we can see that's deployed. So let's add those changes. So we've got our permission for the load balancer to invoke Lambda, the target group for our Lambda as well for the load balancer. We've got the security group for the load balancer, ingress rule for the internet, load balancer definition itself, the default action for the listener and the port the listener's listening on, and then our first rule, which is going to forward to our Lambda target group for any head or get request. Excellent. So we're adding our load balancer to the workload to forward requests to our Lambda. Excellent. Alrighty, so if we just go and have a look at our stack over here, have a look at our resources, we should now be able to visit our load balancer, and we can grab the DNS name and chuck that up here. Let's have a look. What do we get when we hit that? Got our short warm-up time there for Lambda. Oh, that's interesting. So we've downloaded a file. Or we would have if it wasn't for the insecure warning. Thanks, Chrome. Let's have a look. So I'm going to paste the whole thing. Let's give it our file. So index.html. Okay, and that's returned the content verbatim. That's interesting. That's not quite what we were after. Okay, so 200, and we've received content. Okay, so we can see content type is incorrect here. So actually no, that's actually correct. So it's not text plain, which is what we had for our. So if we jump back over here, if you remember for our automatic response for a 405, we were saying text plain. Text HTML is actually correct, but it has not converted it from an octet stream, which is, well, base 64 stream. So if we come back up to, sorry, no, we'll go into our Lambda function. So that's here. So I can already see there's a typo. So this key is invalid. So we have a base 64 string, and we're saying that it's base 65 encoded, which is not going to work. So let's fix that. Yes, let's commit it. Fix base 64 typo. Let's build it. Push the changes. Should be nice and quick again because we've already got some cached layers up there. Yep, there we go. And then we'll deploy that change. Okay, so that says update complete. And we've, yep, there we go, cool. So let's go back over here. Index HTML, we'll run that. Hey, there we go, and we've got our React app. Now, in here, we're actually handling the route mapping as well, route path. So let's remove the index HTML from that, because we want to make sure that our route path mapping is working as well. And that's not what we want. Except I'm not going to be able to inspect the network for that one, because it's not a page. So what I suspect has gone wrong there is that because it's a route mapping, we're effectively, so when we reply to the load balancer, we don't have a file name from the request that came through, so it's blank. So for instance, if we directly request index.html, that response back to the load balancer is able to determine based on that file type, this is text HTML, and it can automatically configure it. However, when it's blank, it doesn't know what it is. So in this case, we've read a file, we've base 64 encoded it, we've told the load balancer it's base 64 encoded, but it doesn't know anything about it. So we can address this by going and implementing our own content type handling, and this is going to give us the ability to explicitly tell Lambda, allow Lambda to tell the load balancer what it needs to do with it. So let's go ahead and do that. So we're going to, up here we're handling that mapping and defaulting a file, so it makes sense for us to default the content type as well. So let's create another constant here. Now this is probably, it's going to be based, it's going to be exactly the same actually as what we've got here. So let's just borrowed this, and instead of dealing with a page, what are we doing? So we're mapping the root to index HTML, so we know that that MIME type is going to be text HTML, and if it's anything other than that, as far as our variable goes, we don't really care, so we can allow that to be null. Now we're going to need to return the content type, so we can append that to our headers. So we could just put it in here, but by putting it here, we're going to be explicitly defining content type all the time. And at the moment, it's automatically determining that based on the type of file that's being retrieved. In most cases, it's just root we want to cover. So let's only include it if content type is actually set. So if content type, so as long as something is there, we can then, so response dot headers content type, make sure we get the header correct, so case is correct, and this will be content type. Actually, let's just rename that so it's file content type. These are all file related constants. Excellent. So what's going on here? Spelling mistake, yeah. Cool. So if the content type exists, we're going to include it in the headers. And we're only actually setting that to a value other than null when it's a root path. So that seems pretty reasonable. Let's give that a go. So we'll include that. We'll include that change. So fixing content type. Oops. Handling for root path. Cool. Build that image. Push it. We'll redeploy. So if this is working as expected, this should allow us now to be able to request the site root and get that default file. So if you had any other kind of file that you had as your entry point from the site root, you could obviously put that in instead of index HTML. That's what we need for this example, so we'll go with that. Jump over and check this. So Lambda's getting updated, which shouldn't take too long. Cool, update complete. Just wait for our command line to come back. And there we go. And if we head back over to our request, so our load balancer has not changed, it is the same. We just want to be able to remove the path mapping from here and, fingers crossed, actually get the right page. No, that's fun. Okay, so I think what we've actually done, we'll probably find that there's an error in the code. If we where's our log group? We're in resources, right? Okay, log group here. So if we check our log group, we're not actually getting anything useful in here. We need to add logging. So let's just have a quick check at this. Text, that looks alright. That was copied from that one. File content type. There we go. File content type. So build, push, redeploy. Yeah, we haven't added anything else. So response, headers equals that. Yeah, so that should be fine. So we really do need some logging in here as well. So it would probably be good to enable us to see these logs in CloudWatch. So let's do an error log here, and we'll just log the raw error event itself. That way we'll get some visibility inside. What's wrong with this console? Oh, because it's in the return. Hang on. If we take that out of the return, console.error. Cool. So now we should be able to see failures. Might be useful to know what this thing's actually doing as well. So let's do a console.info level. What do we want to say? Retrieving file, maybe? Retrieving file. What file are we retrieving? File name. Cool. So now we'll be able to see what file we're actually getting. Might be worthwhile that if we're adding a header, we might log that as well, hey? So console.log defining content type. So defining content type, yeah, so that way we can actually see what content type for this file is being used. So just before we do anything with that, now that we've redeployed it, let's just see. Okay, there we go. So we've fixed our problem from before. Excellent. So let's add these logs. All right, cool. So we'll build a new image, and this time around when we go and do those requests, we'll be able to actually see them in our CloudWatch logs. Push. And we'll deploy that change. Wait for that to complete. And there we go. So if we refresh this, we can also inspect what's going on here. So on the network level, refresh. If we have a look, this was the request to the root, and we can see it's now text HTML. Excellent, that's working. We should also be able to see. Okay, so these are all being downloaded constantly. There's, even with hard refresh, Yep, standard refresh. There's no caching. So that could be something else that we will address in probably the next video. But if we go and jump into CloudWatch and we come to our latest stream, we should be able to see some log entries. Oh, there we go, retrieving file, js.map. So there's a few extra interesting things. CSS. There's the requests. This one, JavaScript file, text HTML. Okay, this looks like what we want. Yeah, retrieving file index HTML, and we've defined our content type. So that's from hitting our default path. So we're starting to get some more interesting logs now in CloudWatch, whereas before it was quite boring just with Lambda starting and stopping and telling us how much each execution had cost us in time. Great. All right, well, that's a good place to stop for this one. So in the next one, we'll work a little bit more on that. We'll get the caching working. So we'll add another header in there to fix that. And we'll start looking at the implementation for Nginx so that we can work towards our ECS support. So we'll follow up in the next video.